Hi everybody. So this is our type 2 projectiles video. We're moving on from type 1, going into trajectory with an arc, starting and ending usually at the same height. That's what we're going to call our type 2. Okay. All right, so our first one, the human cannonball. Mr. Emmanuel Zacchini was a human cannonball for the Ringling Brothers Circus. He was fired out of a cannon at a speed of 24 meters per second at an angle of 40 degrees above the horizontal. If he landed in a net at the same height and 56.6 meters away from the location at which he was fired, how long was easy in the air? Hence, split your X and Y axis information. So let's draw this first. So we have a cannon, right, on some platform. And then he explodes out. Well, here, let's get a better arc on all of that, shall we? So this is at, again, theta right there is 40 degrees. And that net is going to catch him right at the same height that he started. Okay. Now we want to know how long he was in the air, so we want to know a time. So let's look at what we're given. He is fired out of the cannon. V naught is 24 meters per second. Theta is 40 degrees. And delta X is 56.6 meters. Okay, so that's what we have so far. What we want is we want time. All right. Now let's break this up into the X and Y components. Okay, so X, Y, we have delta X is 56.6 meters. Delta Y is 0. Right? He starts and ends at the same height, so delta Y is 0. V naught X, what is V naught X? We did this in the other video. He's shot out at an angle at 24 meters per second, right? So to find the X component of that, we will do V naught cosine theta. And I'll do that triangle again real quick as a refresher, right? So if this is V naught, that's your X and your Y, and here is your theta. Cosine theta is adjacent over hypotenuse, which would give you the X over V naught. So if you want that X component, you would multiply your V naught over to the other side, right? So this would be 24 cosine of 40. Now, if we want Vy, we will do sine, because sine theta is opposite over hypotenuse, so you'd have the Y component over V naught, the hypotenuse. If you want that Y component, you just multiply your V naught over to get V naught Y, right? So that means that V naught Y over here is 24 sine of 40. Okay. Let's see what we can get conceptually for V final, right? So acceleration in the X is going to be 0 still. There's no air drag. Acceleration in the Y over here would be negative 9.81 meters per second squared. But let's look conceptually. If he is launched up with a certain, here, let's do this. He has a certain V naught Y component, right? Now, when he lands, his V final in the Y should be just the negative of that Y component, right? Because he will start up with a positive velocity. Up here, Vy will equal 0, right? Because he starts with a high Y component of the velocity that is going to reach 0 once he peaks, and then it's going to accelerate back down. And we did this before when we did the blue problems. if you'll remember, if you throw something up with a certain velocity, when it comes back down to your height, it will have the same velocity, just in the opposite direction, right? So the opposite velocity. So we actually know V final. V final in the y would be negative 24 sine of 40. Now we do know V final in the x because there is no acceleration. So that would still be 24 cosine of 40, right? Now, we need time. So let's look at time. We have the same amount of givens on each side. We actually know over here, we could include in this bunch that we know the V final. That would also be negative 24 meters per second. So if we want time, let's look at our equations. Okay. We have V final equals V naught plus AT. We have V final squared equals V naught squared plus 2A, we'll say delta x. We're going to apply this to delta y too. We're going to analyze this in a second. Then we'll say delta x equals V naught t plus 1/2 AT squared, right? Now, should we use the x or the y to solve this? We've got two issues in doing this math. Delta y is 0, and a is 0 in the x direction. So if we wanted to find time, we don't want to use this one, right? Because there is no time. So if we use this equation in the x, that would give us V final minus V naught over A equals t, but this would be a 0, and then it all blows up. So we don't want to do that, right? That won't work. So we can't use the x for this problem, or for that equation. We could use the x here. That would go away. Then we would have delta x over V naught x equals t, right? Now, what if we did the y? Let's look at the y component, right? So this time delta y is 0. So here, a is not 0, delta y is 0. So that means that this would be 0. We have V naught. So this would basically turn into a quadratic, which we could do, right? That would give you t is negative V naught plus or minus square root V naught squared plus 2a delta y, but that goes to 0 all over a, right? So that's a possibility. Let's look at the other one. If we have V final minus V naught over A equals t, that's also a possibility, right? That's actually going to end up being the same thing. Because here, negative V naught, that is V final, right? So we would have V final, we would have to do a minus, because if we did plus, you've got negative 24 sine 40 plus 24 sine 40, that's 0. So that would be VF minus V naught over A. So once you do this problem or this problem, you're going to get VF minus V naught over A equals T. So let's actually do both real quick. I'm interested to see if we're going to get different answers if we solve for time. So V final on this side is negative 24 sine of 40 minus 24 sine of 40. You could also just do 48 sine of 40, right? And then divide that by negative 9.81. Let's see what we get. Okay, we've got negative 24 sine of 40 minus another 24 sine of 40 divided by negative 9.81. Oops, need some parentheses on that. Come on, calculator. Get up and move. All right, parentheses. All right, so I got 3.14514, kind of close to pi. So over here, t, let's just say it's 3.15 seconds, okay? Now, let's do it for the x direction. Let's see what we get if we do that, okay? So we have delta x is 56.6 meters divided by v naught, which is 24 cosine of 40. 56.6 divided by 24 cosine of 40. I got 1.81. Whoops. 1.81 seconds. So those are very different, right? Now, let's look to see why that is. If we are looking at the x side, right, we are just looking at how long it takes to go from 56.6 meters, how long it takes to go that distance if we are going 24 cosine 40 with a velocity. But we don't actually just go that distance, right? We didn't go from here to here. It was not some straight line, right? We did not actually travel that distance. But if we look on the y side, right, we are looking at if we start with this velocity and end with this velocity, with this acceleration, what is the time? So that is actually showing the path along which we traveled, right? So they're finding two technically different things, okay? But that is why that we got two different answers, and that is why we will stick with 3.15 seconds as the answer, because the other one, it's also just a general red equation. It's not really taking into account any kind of change. It's talking about a straight line travel, but there was no straight line travel, right? There was acceleration, just not in the x, and the x can't see that because the x doesn't have that information. So the answer to this problem is 3.15 seconds, okay? All right, next problem, a stone's throw away. A ne'er-do-well throws a stone at an initial speed of 20 meters per second at an angle of 30 degrees above the horizontal. If the building is 40, oh, is he throwing it off a building? Oh, yikes, yeah, he is. Okay, so he throws a stone off a building. If the building is 45 meters tall, how long is the stone airborne? Okay, so it is going to go a long ways. I'm going to get a quick drawing real quick just so we can understand what's going on. Ne'er-do-well, rock. Throws it 30 degrees above the horizontal. Throws it really fast. And that building is 45 meters tall. That means that it's going to start up top and it's going to go all the way down, splat on the ground, right? We do not know some of the information here. Now, let's break down our x and y, okay? In the x direction, delta x, we don't know. V naught x, that would be 20 cosine 30, okay? Acceleration in the x, that would be 0, meaning that v final in the x is also 20 cosine of 30. And we are trying to find time, right? It asks how long is a stone airborne. Okay. Now, let's get the y information. Delta y is negative 45 meters. V naught y is 20 sine 30. Acceleration in the y is negative 9.81 meters per second squared. And v final in the y is negative 20. No, it's not. Oh, whoops, we don't know that. Because it is traveling much further. It didn't just stop where it left, right? It's not just a clean arc. So we don't know v final y, but we also need time. Okay. So let's break down the equations that we have. Okay, we've got v final equals v naught plus at. We had v final squared is v naught squared plus 2a, I'll just call it x. Then we have v naught t plus 1/2 at squared, right? Now, if we need time, right, let's look at the x. X acceleration is 0. So x is again going to lie to us because we don't have delta x, right? We have no idea what that is. A is 0 and we need time. So we don't want to use this equation here. It'd be interesting to find that, but that doesn't tell us anything, right? Because if we find that, that would be v final minus v naught over a, which is 0. And this up top would also be 0. So we've got 0 over 0. That won't work. So that's dead. Let's see. If we solve the second one, there's not even time in that. We have all of that information, v naught, v final, and a. So that doesn't help us. And then if we solve for a quadratic, we've got negative v naught plus or minus square root v naught squared, because 2a delta x, that's 0, because acceleration is 0. Divide by a, that's also 0. So none of these will work. Can't solve it with x, right? That's not going to happen. So let's try y. Let's see if I can get the squiggles out. Okay. So we're going to solve using y. Let's see what we can get. All right, so nothing is 0 in the y. We don't have v final, and we don't have time. So v final, I think we should solve for v final, then find time. Because we have v naught, we have a, we have delta y, find v final, then we can plug it in up here to find time. Down here, let's see if it works on the quad. Negative v naught plus or minus square root v naught squared plus 2a delta y all over a. None of that's 0. Should work. All right, let's do the quad first, and then we'll check our answer with the other method. Okay, so that is negative 20 sine 30 plus or minus square root of 20 sine 30 quantity squared plus 2 times negative 9.81 times negative 45. It's a messy square root. Sorry, I should have used this rest of my room. All divided by a negative 9.81. So let's see what we get when we plug that into the handy dandy calculator. We've got negative 20 sine 30. We'll start with plus. Then we've got 20 sine 30 squared plus 2 times 9.81 times 45 divided by negative 9.81. Let me see if I put that in right. That looks good. All right, that gave me a negative time. So let's try minus the square root. That gives me 4.22. 4.22 seconds. That's believable. I mean, it's got to fall a pretty long ways. All right, so let's try this other method. we have v final equals, we'll do that v final squared first. So we have v naught squared plus 2a delta y. That looks familiar. We just did that. Okay, so let's look at this. I'm going to solve the top one. T equals v final minus v naught over a. That is the exact same thing, right? Yeah, that's going to end up being the exact same thing because v final is going to be negative, right? So this sucker will be negative right there. We already have the negative, it's all the same thing. So that will also equal 4.22 seconds. Isn't that nifty? Isn't math just crazy how that works out? All right, so the time for this stone to hit the ground, it is airborne for 4.22 seconds. Okay. All right, now what we're going to do is this is something that we usually do in class. You can do this if you want. I obviously can't make you because it's YouTube. I can't tell what you're doing. But go to a wall in the room and make a measurement of your vertical leap. What I want you to do is hold your arm up on the wall and then just take a standing slap on the wall. And wherever the tip of your finger is, make a mark on the wall. Then measure how high that is, right? Then we're going to make calculations to find your hang time. So if we're going straight up and straight down, right, that is a type 2 projectile. That's what I want, type 2 projectile. So let's see. We want to find time, right? So time would equal v naught plus or minus your square root of v naught squared plus 2a delta y all over a, right? But we don't know what your v naught is. What we know is your delta y and the acceleration with y. We do know that v naught is going to be negative vf, or you could say vf is negative v naught. It's the same thing. But we don't have time. So let's see what we can do about that. We have v final equals v naught plus at. We have v final squared equals v naught squared plus 2a delta y. And we have delta y equals v naught t plus 1/2 at squared. So what we're going to do, this is going to be a common strategy for type 2 projectiles or something similar to this. What we're going to do is we're going to imagine that you are at the top of your jump and coming all the way down, right? Because we know delta y, okay, that is going to be some negative amount of meters or centimeters, whatever you measured, right? Then we know acceleration is negative 9.81. That also means that your v naught equals 0. So that gives us a given. It's a trick. So we have v naught, we have delta y, we have the acceleration in the y direction. All we don't have is v final and a in the y, because this relationship is no longer valid. I'm sorry, we have acceleration in the y, we don't have time. So if we look over here, we have v naught is 0, go away, go away. Then we have square root of 2a delta y over a. Let's see what that is, okay? So if you measured your jump, your hang time will be plus or minus the square root of 2 times negative 9.81 times your delta y. Remember, delta y should be negative, all divided by negative 9.81. Okay, and that's how you can calculate your hang time. And this is a pretty nice trick, starting at the top and then traveling down, right? Because we're not wrong. We're not lying and making up the physics. This is a valid physics trick in trying to find out information using this method. We'll have to use this in the next video when we start doing some harder projectiles. But if you want to calculate your hang time, you can do so right here. If you guys want to watch me jump, I've got a video of me jumping. I'll put it in right here.